Welcome to Programming Fluency. This is section 3.2, the switch statement. In the last section, you built decisions with if, else, if, and else. In this video, you meet a cleaner tool for one very common job, matching a single value against a list of choices. It is powerful, but it has one famous trap. Let's learn both. Let's start with the big idea. A switch takes one value and jumps straight to the matching choice. First, we see why you would ever want it. This is the plan for this video. First, we look at why switch exists. It is a cleaner tool than a long else-if chain when you are matching one value against a list of choices. Next, you learn the anatomy of a switch. You will see how the cases, the break statement and the default case fit together, and how each part runs. Then we study fall-through. You will meet the famous missing break bug, and also see how to use fall-through on purpose when you really want it. Finally, we talk about when to reach for a switch. You will compare it with else-if, and learn about the things a switch simply cannot do. Imagine a program with a menu of many options. With an else-if chain, you test the same variable again and again. Day is equal to 1, day is equal to 2, day is equal to 3, and so on. Look closely. Every branch does the same kind of thing. It compares day to a constant value. The logic is simple. Match one value from a list. But the else-if syntax makes it look busy and repetitive. This is the same logic written as a switch. It is much cleaner. Each case sits on its own line, and the matched constants line up neatly. The value being tested day appears only once up top in the parentheses. For anyone reading the code, it is clear at a glance. This is value matching. The word switch means take this value and jump to the matching case. A switch statement evaluates an integer expression and jumps to the case label that matches that value. The expression must be an integer type. That means int, char, short, or long. And each case label must be a compile time integer constant, a value the compiler knows before the program runs. Switch works in 3 steps. First, evaluate the expression in the parentheses. Second, jump to the case whose constant matches, or to default if none match. Third, run the statements until it hits a break. This figure shows the cascading match. Start at the top and evaluate day. It checks each case in turn until it finds the one that matches and runs that case's code. The expression day is evaluated once. Then control jumps straight to the matching case. And each break exits the switch, so only the matched case runs. The diagram looks like a long chain of comparisons, but behind the scenes, the compiler may build a jump table that finds the matching case directly, without checking each case one by one. This is one reason switch can be faster than a long else-if chain. Every case block should end with break. Break immediately exits the enclosing switch block. Execution then continues with the first statement after the closing brace of the switch. Now comes the single most important rule for switch. C does not stop at the end of a case. Let me say that again. C does not stop at the end of a case. After running a matched case, C keeps going into the next case and the next, until a break stops it. This is completely different from else-if, where only one branch ever runs. So what happens when you forget the break? Let's say day is 3. Look carefully. There are no break statements here. The switch jumps to case 3 because day is 3 and it prints Wednesday. But with no break, it does not stop. It keeps going. It prints Thursday, then Friday, then invalid. 4 lines instead of 1. This is called fall-through. The case labels are just entry points, not stopping points. Once execution enters the switch at a case, it runs every line after it until a break appears. This is the bug that trips up every single beginner. Let's be clear about why fall-through happens. The case labels are entry points, not boundaries. Think of them as doors into the switch. Once you enter through one door, you walk straight through all the rooms after it. Once execution enters at a case, it keeps running downward. It does not go back and check whether day is equal to 4 or day is equal to 5. Those checks already happened at the jump. It just keeps running. Only a break or reaching the end of the block stops it. This behavior came from C's ancestor, the B language. Most people consider it a mistake. Modern languages like Java, C#, and Go removed it. In C, you must remember it yourself. The default case handles any value that does not match a case label. It is the switch version of the final else in a chain. It is optional, and it usually comes last. In this example, if choice is 7 and there is no case 7, execution jumps to default and prints invalid 7. My advice is simple. Always include a default case. Even if you believe your cases cover every value, a default protects against surprises. Since char is an integer type, switch works directly with characters. This is often cleaner than a chain of character comparisons. Each case uses a character literal, like capital A or capital B, written in single quotes. Under the hood, switch compares the integer value of grade against the case constants. Remember, the character capital B is really the number 66, so this is the exact same mechanism as switch with int. Characters are integers. You learned that back in chapter 2. Fall-through is usually a bug, but sometimes it is exactly what you want when several values should trigger the same code. Look at this vowel classifier. Case A, case E, case I, case O, case U if letter is the character E. Execution enters a case E and falls through the empty cases until it reaches the print statement after case U. All 5 vowel cases share the same line. The key point is this. The cases that fall through have no code between them. They are just a list of values that all do the same thing. This pattern is clean and very common. There is a second kind of intentional fall-through where the cases do have code. When you do this, you must leave a signal. Look at this discount example. If level is 3, all 3 messages print because there are no breaks until case 1. The discounts stack up. If level is 2, only the last 2 print. The comment // fall through tells future readers and future you that the missing break is deliberate. It is not a bug. Without that comment, anyone reading this would assume you made a mistake. Switch has restrictions that if and else if do not. Let's walk through the 4 of them. First, integer types only. The expression and the case values must be int, char, short, or long. You cannot switch on a float, a double, or a string. Second, constants only. Each case value must be a compile time constant. You cannot write case x, where x is a variable, not even a const int. Third, equality only. Each case tests exact equality. You could not write case greater than 90 for a range. Fourth, no duplicate cases. 2 case labels cannot share the same value. These limits tell you exactly when switch is the right tool. So how do you choose between switch and else if? This table sums it up. Use switch when you match a single value against specific constants. That covers menu selections, command codes, and state machines. Use if and else if when you test ranges, like x greater than or equal to 10 and x less than 20. Also use if and else if for floating point values or conditions that involve several variables at once. The simple rule is this: if every condition looks like a variable is equal to a constant, use switch, otherwise use if and else if. Let's end with a mistake you will make at least once: a missing break. Suppose grade is capital A your case a prints excellent, but you forgot the break. So execution falls through in the case B and prints good, then case C and prints average. You wanted one line and got 3. The fix is simple: add a break after every case, and build a good habit. Compile with the flag -w implicit -fallthrough, which is part of -w extra. The compiler then warns you whenever a case falls through without a break. Let the compiler catch this bug for you. Let's recap. The switch statement matches a single integer expression against constant case values and jumps to the match. End every case with break, or execution falls through into the next case. Default handles any value that matches no case. Fall through is a bug when it is accidental, but a useful tool when it is deliberate. And when it is deliberate, always add a comment. Remember the limits. Switch is integer only, constants only, and equality only. Use switch for simple value matching. Use if and else if for ranges and complex conditions. So far your programs make one decision and move on. Next, you will learn to repeat actions with C's 3 loops, for while and do while.